Hi, this is my second code review and refactoring session. Recently, a developer asked me to review this feature. It's a filter bar that can be used to filter the data in the table. When the user changes a filter, it is added to the URL as a query parameter. This way, it persists a page refresh and can be shared with other users. Let's check out the code. This is the filters component. You can see there's a lot going on at the top already. Lots of variables with unclear purpose. Then we have a few change handlers. Handle change is connected to the project name input. Handle level and handle status are connected to the select components. Handle project name is called from handle change and from the use effect. The use effect listens to changes in the filters as well as to a URL query parameter called page. This is used for pagination in the table. The use effect is responsible for updating the URL with the newest filter parameters. You can also see a condition inside. This code is supposed to run when there's a project filter in the URL, and this is the first render. So basically, this code is used to initialize the project name input with a value of the project query parameter. Note that this code doesn't work. isFirst is a ref, so it's always truthy. isFirst.current should have been used instead. Also, for some reason, during testing, this code doesn't seem to be executed anyways. Then we see two select components rendered, as we saw in the website. One is for the status filter and one is for the level filter. These select components look a bit unconventional. They seem to be uncontrolled, and each option has a handle callback assigned. Also, the value of each option is the same as the display text. But if you pay close attention, you realize that the filter values in the URL are different from the display text. And finally, we have an input component that allows the user to search for data related to a project. So let's dissect this code one by one. First, let's check out the filters variable. The filters is currently only used in the use effect. Any change in the filters triggers the use effect. The filters are also used to create a new query object. And by calling router push, the new URL with a new query params replaces the current URL. It's interesting that the filters object is only used in the use effect. It's not connected to any of the input elements like the select components here. The filters are updated via the handle filters function that is returned from the useFilters hook. And the handle filters function is called inside the change handlers. For example, handle change, handle level, handle status. These are connected to the select and the input component. Now let's have a look at the useFilters hook. The useFilters hook is simple. It just exposes the filters context. The filters context itself is also not very complex. It basically contains the filters object in a state and exposes a handle filters function that is used to update the filters. To get a better picture of what's happening, let's have a look at the data flow. On the initial render, the state in the context contains a filters object with undefined values. The URL doesn't contain any query parameters. Once the user changes the filter, the state in the context updates and one of the fields is set. The URL still doesn't contain any query parameters. The update of the state in the context triggers a re-render of the filters component, and the use effect also runs. The use effect updates the URL, including the new query parameters. And this route change again triggers a re-render of the component. This doesn't really have an effect, and performance-wise it's also not super important, but it's important to keep in mind. And this is what it looks like in the code. When the user selects a filter, for example the level filter, the handle filters function is called. This is a function defined in the context and updates the state in the context. The state update again triggers a re-render of the component, and since the dependencies of the use effect changed, the use effect is run. This in turn calls the router push function, which updates the URL with the new query parameters. The core problem that causes some complexity in the filters component is that we duplicate the filter values. We store them once in the URL and once in the context state. So we always need to ensure that the values in the URL and the state are in sync. But is there maybe a simpler option? There's one hard requirement for this feature. The URL should contain the filters as query parameters. This way, the filters persist a page refresh, and the URL can be shared with other users. So what about the state in the context? Maybe we don't need that. Let's see what the data flow would look like if we removed the state in the context and directly updated the URL query parameters. On the initial render, nothing would change. The filters would be undefined and the URL wouldn't contain any query parameters. Once the user changes a filter, first the URL would update. The value of the filters would still be undefined. The change in the route would trigger a re-render, and since the filters are directly derived from the query parameters, our filters would change. This might not look like a big change, but you will see the effect in a bit. But first, let's continue with the code review. As I mentioned, the project name input contains some kind of autocomplete functionality. We can see that the code searches for a project name that matches the input and then uses this name to update the filters. Let's set a breakpoint to see it in action. Once we enter a few letters, the code execution stops. The name that is returned here is front-end web. And here's the complete list of project names. Now when we continue code execution and have a look at the web app, we can see that the URL updated with the project name. This kind of autocomplete functionality is a good idea, but the implementation is a bit buggy. For example, what happens when there are multiple projects with a similar name that match the input? This code would simply select the first one and omit the results of the other projects. Since the user doesn't know that there's this kind of autocomplete functionality, they would be surprised to only see the results of the first project. Also, when we clear the value from the input, nothing seems to happen. Only when we enter another letter, the URL parameter is cleared. So clearly there are a few bugs. As a final point of this code review, I would like to mention the programmatic styles. You can see here that we get the window width via a hook and that we check whether the user is on a mobile screen or not programmatically. We also use this flag to see if the mobile menu is open. These flags are then used to assign styles to the select and the input components. This seems like a hacky workaround to some problem that the author encountered. We'll try to replace these by normal CSS and media queries in the refactoring. So let's start the refactoring by replacing the useFilters hook. As we saw in the new proposal for the data flow, we could completely get rid of the filters context. We get the router from the useRouter hook and then create the filters object using the values from the router query. To update the filters, we create a handle filters function. This accepts the new filters as a parameter and creates the new query from the current query and the new filters. Then we call router push to update the URL. Since this is a TypeScript project, we also need to type the parameter. We already have a type for the issues filters. It looks like this. Now we simply return the filters and the handle filters. Let's check the return type of the useFilters hook. For now, it simply returns an object as filters, but we would like to return the issueFilters type. So we simply cast the filters object to issueFilters. Now we properly type the hook. We can see that the author of this code introduced a good abstraction layer by using a custom hook. We were able to change the useFilters hook internally without touching the filters component. Since the use effect is only responsible for updating the URL, we can simply remove it. Let's check the application. And all filters still work. Since the useFilters hook doesn't use the context anymore, we can completely delete the context. We obviously have to remove the remaining references to this context from the rest of the app. Now let's rerun the app, and there's an error. Okay. This took me a bit, but after all, I just had to restart the development server. Try again, and it works. Finally, let's clean up the filters component a bit. We don't need the router anymore here, and the isFirstRef is also not necessary anymore. This was used inside the use effect to trigger some code only on the first render. Look at these changes. We got rid of so much code and so much complexity by simply using a single source of truth. Now let's create a commit and move to the next step. As you can see, we still have a bug in the code. This was also present in the original implementation. When we have filters set in the URL and refresh the page, the select and input elements don't have the correct value. The reason is that we set the default value to the value of the placeholder, which is already strange, but this is a topic for another refactoring. What we want to do is set the default value according to the URL parameter. So let's create a function for this. If the status filter is not set, we return the current default value status. Now the rest is a bit tricky. The status filter can have a value open or resolved, but the user should see unresolved and resolved. So we need to transform the filter values. If the status is open, we return resolved, otherwise we return unresolved. Now we create a similar function for the level filter. This is a bit simpler because the level matches the display values. We only have to capitalize the filter value. Now if you think it's strange that we need this kind of functions to get the default value, you're right. The implementation of the select component is a bit unusual, but again, this is a topic for another refactoring. We will leave the select component as is for now. So now let's use the dynamic default values. And when we refresh the page with query parameters in the URL, we can see that the select components have the correct default values. But there's still one problem. The project name input isn't initialized correctly yet. I'm not sure why this happens, so let's set another breakpoint to see what the filters value looks like on the initial render. The value of the project filter seems correct. So let's check the filters component again. Alright, we need to initialize the input value state correctly. We don't need to define the type on the state here, so let's remove it. Then initialize the state with the project filter. Okay, there seems to be an error. Okay, the input doesn't accept undefined, so let's use an empty string as default. Now refresh, and we see that the input is initialized correctly. So let's create another commit before moving to the next step. As mentioned, the project name input uses some kind of autocomplete functionality. But we also saw that it was buggy, so let's remove that. We can directly update the URL whenever the input changes. This seems to work, but this might have some performance indications. My best guess is that the whole page is updated whenever we change the URL parameters. So let's add a console log statement to the page. Now when we change the project name input, we see that the whole page re-renders. Since React is quite efficient, this might not be a problem in fact. So let's see if the browser repaints the whole page as well on every re-render. This doesn't seem to be the case, so the impact on the performance of the application might not be that high. But with every change of the filters, we also send a request to the API, and we might not want that. To prevent every keystroke in the project name input to trigger a new request, we can debounce the updating of the filters. There's a nice small npm package called useDebounce. Let's see how it works. It seems pretty simple to create a debounce callback like this. Let's give it a try. We want to debounce the handle filters function. For some reason, the useDebounce callback isn't imported automatically for me, so I have to do this manually. We want to debounce the handle filters function, so let's pass it there. 300 milliseconds should be okay. Now in handle change, we can use the debounce function. Let's rename the parameter. We don't need the handle project name function anymore here, so we can simply remove it. But wait, I guess we had to transform the project name. This should actually be to lowercase instead of to lowercase. Let's check if the app is still working. And yes, the input doesn't seem to update the URL immediately, but with a slight delay. So now we can clean up the filters component again a bit. Here are the changes. So let's create a commit. Next on the list are the programmatic styles. Let's first remove the workaround for when the mobile navigation menu is open. Here we can see what the workaround did. The select and the input components are overlaying the mobile navigation. Obviously, we can just hide the select and input components, but what is the actual reason for this? Let's have a look at the CSS of these elements. I can't really see why this happens from the element style. So let's look at the navigation. Here you can see that one of the parent elements of the navigation has a position fixed. Let's set z-index to 1. And yeah, this fixed it. So how do we change this in the code? Here we can see the name sidebar navigation. So let's see if there's a component like this. Yes, there is. And the element should be fixed container probably. So let's see if that exists. And yeah, we have the fixed container there. And this should fix the issue. Perfect. Now we can remove the navigation context here and here and create another commit. And then finally, let's handle the conditional styles based on this programmatic mobile breakpoint. This project uses styled components, so we can simply style our select component with custom CSS. With styled components, you often run into this kind of naming conflicts. So we rename the original component to unstyled select. We use a mobile first approach. So we define the mobile with first and then use the breakpoint from the other component. Note that this breakpoint function is a custom utility function and doesn't belong to styled components. Now we replace the select component in our filters component with the new styled component. And let's do the same with the input. So these are the mobile styles. And these were only set on mobile, so we basically need to unset those on desktop. I simply guessed the width here. Let's remove the programmatic styles and use the styled input. And we can see that the styles are broken. So why does this happen? Let's inspect the components. Okay, this seems to have some additional padding that lets the input overflow. So box size and border box seems to help here. And the select elements seem to have a width hard-coded. So this is again an internal problem of the select component that we don't want to fix here. And the width should be 100% instead of 97. Now we can clean up the filters component again. We might even remove the React use dependency here. And let's create a final commit. I'm still not really pleased with the default value functions and the change handlers, but we need those at the moment because of the implementation of the select component. In the next refactoring session, we will have a closer look at this. But apart from this, I'm pretty happy with the result. We were able to remove a lot of complexity, especially by migrating to a single source of truth. If you're interested in more videos like this, subscribe to my channel. In the description of this video, you can also find a blog post for this refactoring session and a link to the GitHub repository for this code. I hope you enjoyed. See you next time.